Welcome back. We have another physics practice problem, and in this one, we have a pole vaulter. He's running up to the, whatever you call this, I'll call it a field goal. I sound probably very dumb to all the pole vaulters out there, but they drive the thing into the ground and they come over and they do their nice little satisfying thing. This pole vaulter of 51 kilograms has a vertical displacement of 4 meters. What is the change in potential energy? So we are asked change of potential energy for this pole vaulter as their center of mass raises 4 meters to overcome the pole. So what do we know that, before we get into what actually is a change in potential energy, what is potential energy? Potential energy is equal to, what is potential energy equal to? It is equal to mass times gravity times height. Potential energy is your energy based on where you are relative to some surface. So let's say I have a ball here and it's sitting on a ground, right? And we call this h is equal to 0, right? The height is 0, okay? What's the potential energy of it? It's 0. Relative to some ground, the potential energy of that ball is 0. But if I have a ball up here that's, say, like, I don't know, 2 meters, what is the potential energy of that now? Well, it ain't 0. It's mass, it's gravity times the 2 meters of which it is up. Because gravity is going to pull down 9.8 meters a second on that, right? So that is a form of energy, right? Energy is just the ability to do work. And we get that ability to do work through gravity, right? That non-conservative force. So now that we know that potential energy is mass, gravity, height, how do we find the change in it? Well, we know that for something to change, it's final minus initial. Okay, so the change in potential energy, change in PE, let's just substitute some variables. Potential energy final minus potential energy initial. So we're taking our final potential energy and we're subtracting the initial potential energy to find a change in potential energy. So we can actually rewrite this here. The change in potential energy is equal to mass, gravity, height, final, minus mass, gravity, height, initial. Okay? What is something we could factor out? Remember factoring rules from algebra. If we have 3x plus 3y, and we can bring out a 3 here, right? Hopefully this looks a little familiar, and if it doesn't, I'll explain it here. If we were to multiply the 3 back in, these are equivalent terms here. If we were to multiply the 3 back in, we get the same thing here. So this is equivalent. 3x plus 3y is equal to saying x plus y quantity times 3. Fair to say? Okay, moving on. The reason I bring that up is we can factor out a mass and a gravity. So we'll say change in potential energy is equal to mass, gravity, hf minus hi, which basically says it is the change in the final height minus the initial height, right? Because if I were to multiply mass, gravity, height to each respectively, we'd get the upstairs term, right? So we can write this, change in potential energy is equal to mass, gravity, height. What's the mass? 51 kilograms, 51 kgs, that's the mass. What's gravity? Hopefully no gravity at this point, 9.8. And because we have two sig figs, I won't go to 9.81, but it would be 9.81 normally. So meters a second squared. And what's our change in height? Well, we go from, our final is 4, and our initial we'll say is a relative 0. So 4 minus 0, that is 4. So 4 meters, okay? Notice that we're going to get joules here. What is a joule equal to? A joule is equal to a Newton meter. A Newton meter is equal to a kilogram meter per second times meters, okay? Which basically is the same as saying kilograms meters squared per second. And if you look at our units, that is exactly what we get. We get kilograms times meters a second squared times meters, which is a joule. So to put it all together, let us multiply everything together. 51 times 9.8 times 4, you get a change in potential energy of 1,999 joules. Or roughly, I'll say roughly here, roughly 2.0 kilojoules, right? And if given our sig figs, we should round, we'll say 2,000 joules or 2.0 kilojoules, or you could also say 2,000 Newton meters. I hope you guys enjoyed this video. I love making practice problem videos. But anyways, a pole vaulter, doing that, he's going to exert 2.0 kilojoules. So hope you guys enjoyed. Have a wonderful day.